All right, welcome back, guys. Hopefully you just got done working 467 to 468. So here's what I'm going to do. 467 to 468 leads you to this. This is the idea of 467 to 468. And I don't want to stress about the questions on it. If it didn't make sense, it's okay. I'm going to give it to you. All right. The idea here, the magic here, is that the degree of the central angle, or theta, we like to call it, if we're looking at this picture, this would be the central angle. Remember, central angle is formed by two radiuses, okay? The degree of the central angle over 360, that part over the whole, is going to be equivalent to the area of a sector divided by the area of a circle, okay? Whatever that area happens to be, that relationship, that ratio is going to hold. It's also equal to arc length. This says arc length. I know there's kind of a glare on the board. I apologize about that. But this says arc length divided by circumference, okay? So notice what's really fascinating here. These are two-dimensional measurements. These are one-dimensional measurements, but the ratio remains the same, okay? The area of the sector, let's say the sector is a quarter of the circle, right? So this would be 90 degrees over 360. The area of that sector would be 1/4 of the whole area. Well, the arc length would be 1/4 of the entire circumference or perimeter, okay? And so remember, it's just kind of part over whole. Now, here's what I want you to put in your notes if you don't have it. This top part is kind of listed on page 468, and I think it's great, but this is what I want you to have in your notes. The area of a sector, okay? When we talk area of a sector, we're kind of like the cheese on a pizza. So we're talking this little section right here. So we're talking this area in here, that shaded area. That is going to be pi r squared theta, theta being the angle, whatever that happens to be, divided by 360. Okay, and that's going to give you the area of the sector. And then the crust is kind of just this outer part. What part of the circumference is this? So I like to call that the crust. And that is going to be 2 pi r theta over 360. Notice I use pi r squared for area because that's the formula for the area of a circle. And then arc length, we use 2 pi r. Basically what happens is you take this particular section here and you solve for area of a sector and you'll get this. You take this and you get this. Okay, so I want you to use these two formulas and that idea, and I want you to do page 469. We're going to do the whole thing, all right? This section really is practice, practice, practice. So page 469, I want you to do the whole thing. 10 minutes, yeah? Don't take a long time on this. Take 10 minutes and then come back and see me.